Hi there. My name is Tamás. I've been with Formlabs for about 5 years now. I've worked in the software industry for about 10. I've been around software development for about 20 at this point. I joined Formlabs shortly after the Form 3 was launched in 2020, and I've worked on pretty much all of our printers that we shipped since then, including all of the auxiliary devices. What I want to spend a bit of time with you today talking about is we're going to take a brief look at what Formlabs does, what products we have, and how the company works. Then I'm going to talk a little bit about the things that motivate me to build things. I think a lot of you are going to share some of the ideas that I'm going to be talking about there. After which we're going to go through 3 examples of things we built here at Formlabs across the years and where those landed, followed by some lessons that we learned from them. So, Formlabs. The history of Formlabs started with a Kickstarter campaign in 2012, where we shipped the first desktop affordable printer, SLA printer, sorry. There were plenty of other printers before that. And that's essentially what started the story of Formlabs. SLA printers are printers that turn liquid resin into solid parts by curing them with UV light. Since the Form 1, we ended up shipping 4 different generations of products, including the Form 4 and 4L that we shipped earlier this year. Each of them had some differentiator and something that was pretty revolutionary in the way they worked. Next to our SLA product line, we also have a couple of SLS printers. The difference between an SLA and an SLS machine is that while an SLA printer prints from liquid resin, an SLS printer prints from fine plastic powder. Tying all of this ecosystem together is our preform desktop application, which enables you to slice your prints and prepare them, plus control all of your printers and auxiliary devices along the way. The mission of Formlabs is to build the tools that make it possible for anyone to bring their ideas to life. The way we do this today is by shipping amazing 3D printers, 40 plus different kinds of materials that you can print with, accompanied by a bunch of auxiliary devices that help you post-process your prints along the way. Our devices are used by many industries, from aerospace to automotive to medical, education, jewelry, and many, many others along the way. You can see a whole bunch of prints somewhere in the back on the tables that were printed on our devices. Feel free to play with them. They're actually pretty cool. But we don't only like to make tools that enable you to build things. We also like to build things ourselves. The parts that you see there were designed by many of our engineers and employees. And next to the things that we like to print, we also like to design and build software. So, let's take a look at a couple of reasons why I personally like to build things. The first thing is, if I see a problem that is not solved, I have a strong urge to help out, especially if I have an idea, whether that's in my team, in the larger company, or somewhere in my surrounding. The second reason why I usually end up building something is because I want to try something new. I want to explore and learn. Sometimes the mere challenge of building something is enough of a motivator to build something based on it. And finally, if you actually have a problem that needs solving that doesn't have available alternatives or you can't afford them, is also a good enough reason to actually end up building. However, whenever you build something, you must remember what the fox said from The Little Prince. Whenever you build something, you become responsible for it forever. What does this mean in the context of software development? It actually means that if people start using your tools, and they start depending on it, you're the one who's responsible for keeping it running. You're the one responsible for maintenance, the development cost, keeping the expertise in your team to support the tools. You're responsible for fitting the effort of maintaining that in your timeline, and you're the one who's on call when things break. These are things that you shouldn't forget about. With that in mind, let's take a look at a couple of things we built. The first cool thing we built was FuseBuster. We actually launched our first SLS printer in 2017 for the first time. I know I put on the slide 2021. However, the first time we announced it was 2017. We thought we were ready to ship it publicly, but as it turns out, we weren't quite as good at printing from powder at the time as we were from printing from resin. It took us an additional 4 years to actually get the technology and understand what was going wrong so that we were able to ship a printer that our customers love today. Throughout these 4 years, we had to take a look at every single print failure, every single machine, and every single thing we did and understand what went wrong. This meant people were looking at logs from the printers. This meant people were plotting raw data, and this was very annoying. So 2 people on the embedded software team figured, hey, I can help there. They ended up building a tool that later the entire company used to track what happened on printers, what went wrong with the devices, what went wrong in certain prints. It was also a great chance for these people to learn something new. In the embedded development team, we use primarily C++. This was a chance for these people to learn web technologies, Go, cloud infrastructure, how to deal with big data, and so on. It actually became a pretty successful product. We ended up extending its support for Form 3, 3L, and we even used it in order to develop Form 4. How does it actually work? Our printers generate a bunch of logs on disk from the different applications that run there. These logs are then collected by a small application which is aware of what the printer is doing, uploaded into an S3 bucket from where an AWS Lambda ingests it into InfluxDB and Elasticsearch. This serves as the backend of a web application written in Django, where people can actually look at what happened on given printers and during certain prints. The application itself is pretty simple. You can search for example, a printer serial name, which gives you a history of the prints that happened on the printer itself with a bunch of metadata, like the material you printed, layer height, what firmware version was used, who printed it, and so on. If you're interested in one of the specific prints, you can go into more details where you see more information about what happened, including notes from your colleagues about the problems that they have identified so far. If you go further, you have more printer-specific details that you can also collect from there. The application itself was meant to be a single-purpose application to help us ship Fuse 1. Along the way, the application was built with a few assumptions in mind. These assumptions primarily revolved around who is going to touch it, who's going to need to change things in there, and the target audience for it was primarily developers, software developers and print process developers who are pretty comfortable changing code. Along the way, we got a couple of unexpected customers. The tool was very useful. People started relying it in the sustaining engineering team, in the customer support team, which turned a single-purpose application into a multi-team open-ended internal project that had to be supported for many years. By 2023, the original developers who were also responsible for maintaining and developing this tool further left the company, which left the team who inherited this with a stack that was quite unfamiliar for them. This turned into a bit of a headache for us because we had to maintain things that we weren't quite familiar with, leading to delays in bug fixes. We couldn't really ship new features for it, even though people could have really used new things. And eventually, in 2024, we replaced it with pretty standard tooling, where issue tracking is now done in Jira. Our data backend is BigQuery, and every team has its own front end developed in Grafana. This enables them to be far more flexible than we could have ever been with the with FuseBuster. The unfortunate part of this story is that all the tools that we ended up replacing FuseBuster with, even though it was a great product, were already available at the time when we built it. If we would have built the same tool, the same processes on tools that were available at the time, we could have saved hundreds, if not thousands of hours of engineering time along the way. The second cool thing I wanted to talk a bit about is our over-the-air updater. In 2016, we shipped Form 2. This was our first printer which did not require a constant connection to preform over USB. This brought up the question of, okay, but how do you actually update firmware on something that is not connected? And it's at some other customer site, very far away from you. So we had to figure out how to build a mechanism for updating printers in the field without having them connect to Preform. We ended up building a tool based on an application that runs on the printer, some AWS tooling, and a whole lot of shell script. It was meant to be an MVP application with a limited feature set where the on-printer application is tied in very closely with the software that runs on the printers. It has limitations on what an update is, meaning that you can only do a full firmware image update, which in turn means that if you change a setting file, you need to download an entire firmware image. And the original implementation was based on very, very limited information about what printer gets what update. The way this works is on this slide on the bottom half, you can see our release pipeline, which is pretty simple. We have a Jenkins job which creates build artifacts which get placed into an S3 bucket. First, it's only accessible internally. Then as the build moves through the release process, it becomes more and more available for larger and larger audiences. The stage where this is tracked on the top half of it, and it's managed primarily by shell script, today managed by Jenkins through those shell scripts. And the stage where a certain build is stored in a DynamoDB database. When the printer wants to check in for an update, which it does a couple of times a day, it queries an AWS Lambda, which checks the database state, and based on the hash of the build that's running on the printer, potentially provides it with a firmware update URL that the printer goes and downloads from a publicly available S3 bucket and installs on itself. We still carry many of the MVP decisions that were made at the time. Our core problem remains, many of our core problems remain unsolved, even though we've invested significantly in this tool over the past couple of years. We still can't do differential updates. We still need to download a full firmware image for a setting change. We still struggle with the amount of data available, even though we've invested significantly into enabling selective updates. We keep investing into usage tracking and monitoring. The tool itself is a core function in the products that we ship. However, it is not really the core expertise of the team that owns it. This means that anytime we don't touch this for a couple of years, the expertise gets lost or vanishes, and it's always a significant investment to relearn it. There are plenty of alternatives out there that can do this. However, most of them are either pay-per-use or pay-per-device, which makes their commercial license actually very expensive. I'm pretty sure if we actually asked for a quote for them, they could give us a price in the same ballpark as what we pay today for keeping our products alive. However, the cost of switching today is extremely expensive given how intertwined everything is. The third thing that I want to talk about that we built is our remote assistance tool. The year is 2019, we just shipped Form 3. Form 3 is a great printer that allows everyone to print with low-force stereolithography, which in turn enables you to have much, much finer features and less support than you had before. It comes at the cost of a fairly complicated mechanical design, which requires accurate calibration. We are pretty good at calibrating things in-house, but after we started shipping the product, we realized that the factory wasn't quite as good at calibrating our machines. This led to a whole bunch of RMAs where customers had to return their printers just so that they could be recalibrated and shipped to a different customer. In order to fix this, we decided to build a tool that allowed our engineers to connect over SSH to printers that are in the field so that they could run calibration scripts on machines without having to return them. The tool itself was built on top of ZeroTier's free tier, where ZeroTier is a commercially available software. However, the licensing is actually pretty expensive. The choice of using the free tier came as a workaround when we couldn't or didn't quite want to pay the price of the commercial license, which led to us developing the so-called ZeroTier registry, which is an orchestration layer on top of ZeroTier itself. We all know there's no such thing as a free lunch. So at some point, ZeroTier came and said, hey, you're not quite using our free tier as you're supposed to. And we ended up getting a pricing setup that actually worked for us at the time. This meant we still had to use our own build tool around it, which on the flip side had some benefits in terms of security, because it only allowed us to have one printer and one agent at a time connected to the same network. How does this actually work? Essentially, whenever an engineer wanted to connect to a printer, it accessed our zero-tier registry through a web front end, registered its intent that, hey, I want to connect to a printer. And on the other side of this, the printer regularly queried the registry looking for impending connections. Whenever there was a connection request, it would open a zero-tier network and register the network ID in the zero-tier registry, to which then the engineer could connect to, and then there you have basically a private network over different customer networks as well. It was very useful during the Form 3 development and shipping period. It allowed us to save tons of money in not having to ship the printers back. It allowed us to understand much better the issues that were happening in the field. And it's still very, very useful for us today, because we can go and perform calibrations on machines that are in the field or understand customer problems through them. It became standard tooling for a bunch of teams other than just the engineering team, like the sustaining engineering team, customer support, and so on. The tool itself didn't have a particularly great user experience. It was slow, it was clunky, but it worked. It also stayed untouched pretty much for 4 years. However, as I've mentioned before, zero-tier is a business, so at some point they were like, actually there's no such thing as a cheap lunch either, and you're going to have to pay commercial prices. This was a trigger for us to consider moving off and actually fixing a number of other issues we had with the service. So over the past couple of years, we ended up spending, again, significant efforts and investment in replacing the underlying tooling and improving on the user experience quite a bit for the people who use it. At the time, we considered publicly available alternatives to zero-tier, commercially available ones that we didn't have to pay for quite so much. However, we decided to keep our own system because most of it was there. There was an open source alternative. And even though the cost of the publicly available one, commercial one, would have been about the same, we already had the system running and people were used to it. I personally don't necessarily agree with this decision. Basically, it is a tool that is furthest away from our core business, but it is what it is, I guess. The truly sad thing in this is that the tool we ended up replacing zero-tier with existed over 10 years ago, meaning at the time when we built this the first time, it was already there. So, what are the things that we can learn from this? First of all, things grow. Things, especially if they're useful, grow into products that people start to rely on. This means you're going to inherit the problems that your product has. You're responsible for support, ownership, being able to maintaining the technology that your product is built on within your team, and you're responsible for staffing. The second one is keep an eye and keep in mind the cost of your thing. Everything has a maintenance cost, development cost, infrastructure cost, but the one that people keep forgetting about is opportunity cost. If you don't spend your time on the things that are close to your core business, you're spending it on something that does not actually deliver value to your own customers. You should always ask your question, what else could I have spent my time on instead of building this specific thing? Then you should be what I like to call biased, as in have a buyer's mindset. In many cases, there are things that are available out there. Even though something's tempting, try to figure out how you can pay someone else to do it. If there's a commercial business built on solving a problem out there, you're probably missing something from the equation. And if you do end up building something on your own, have a plan for it. Unchecked organic growth is a risky business in software development. Things grow into areas that you don't expect, and a couple of years down the road, you realize, hey, I'm going to have to spend a lot of time and energy and money on fixing this. Have a plan for the technology you're going to use. Have a plan of ownership, who's going to own the thing you built when you're no longer at the company, and have a plan on how you're going to support this down the line. Thank you.